Hello, good evening. Am I audible or not? Hello, good evening. Am I audible? Please let me know whether I am audible or not. मैं क्या audible हूँ? So let us wait for some minutes, then we'll start the session. अगर ऑडियो सही आ रहा है तो प्लीज लेट मी नो ऑन द चैट बॉक्स की ऑडियो सही आ रहा है. हम लोग कुछ देर वेट करेंगे, उसके बाद हम लोग स्टार्ट कर देंगे. If anybody joins, then we'll start the. we are waiting for just कि other somebody will join. Is there anyone who have joined? So now let's start the session. So in the previous lecture we have discussed about the basics of the feedback amplifier. And in the case of feedback amplifier, what we have seen that this was called as the basic amplifier. This was called as the basic amplifier, and this thing was called as the feedback element. This was the feedback element. Okay, so now this feedback element was having a gain of beta, that is the feedback gain. Beta is the feedback gain and A is the basic amplifier gain, और ये दोनों मिला के आपका होता है feedback amplifier. We have already discussed that, and this thing was called the mixture part. So it will mix the incoming signal and the feedback signal. So this Vs is the, what is this Vs? This Vs is nothing but the input signal. This is the input signal, that is input signal, and Vf is the feedback signal, and this V0 is the output signal. So this feedback part is taking the output V0 and mixing with the input signal and it will produce the Vi. So you can see here that there is positive and there is negative. So that means this Vi will produce Vs minus Vf, because there is a minus sign here. Okay, so this is a minus sign, so Vi will be Vs minus Vf, and this Vf was called as the feedback voltage. All of this thing we have already discussed. So this was the feedback voltage. Now we have seen that the total gain, if we consider the overall gain of this amplifier, so overall gain of the amplifier, overall gain of the amplifier with feedback, we have already seen that was AF. AF was equals to, AF means V0, this V0 divided by Vs. So V0 divided by Vs, and that was equals to the basic amplifier gain A divided by, since here it is minus, so that's why it will be 1 plus A beta. We have already derived, हमने ये इसको derive किए थे. So this is the overall gain of the amplifier, that is the feedback amplifier. Now suppose if there is a positive sign here, in place of this, in the place of this negative sign, if this negative sign is replaced by a positive sign, then your Vi, what will be the Vi? Vi will be equals to Vs plus Vf. We have seen that. So if this is Vi equals to Vs plus Vf, if there is a positive sign here, then the overall gain AF will be equals to V0 by Vs is equals to A divided by 1 minus A beta. So if we use the positive sign here, then it will be 1 minus A beta. So this is how the overall gain varies with the type of feedback. If we use the positive sign at the feedback, then that is positive feedback. So that means this formula will be for the negative feedback. We have already discussed what is negative feedback in the previous class. So negative feedback, and this formula is for the positive feedback. Positive feedback. Okay, so we have already discussed this thing. So depending on the sign that we are using in the case of feedback, our feedback was of two types. First one was the negative feedback, second one was the positive feedback, and we have already seen that. So this was the thing that we have already discussed, that is the negative feedback and the positive feedback. In the case of negative feedback, we will use minus sign here, so our Vi will be equals to Vs minus Vf, and in the case of positive feedback, we will use positive sign here, so Vi will be equals to Vs plus Vf. So negative feedback कहाँ पे यूज होता है? Negative feedback will be used in the case of amplifiers. If we want to design the amplifiers, we have to use the negative feedback. So that means in that case we have to use the overall formula like this, A by 1 plus A beta. And in the case of where the positive feedback will be used, positive feedback will be used in the case of designing the oscillator circuit and the multi-vibrator circuit. So if we want to design the multi-vibrator circuit and the oscillator circuit, then we have to use the positive feedback. So in that case, for finding the overall gain of the amplifier, we have to find AVF is equals to A by 1 minus A beta. So this is how the feedback goes. Now we have to go through some other parts also. So the next part is equals to sensitivity. So this is very important, sensitivity. So what is sensitivity? Sensitivity means this sensitivity is defined by the S, and S is equals to, it is a ratio of it will be a ratio, and it is a ratio of, if we change, that is change in the basic gain, that means change in the gain of basic amplifier. So basic amplifier का जो गेन है उसको अगर हम लोग चेंज करते हैं, for that how much will be the change in the feedback gain. feedback gain में क्या चेंज होगा? feedback gain मतलब आपका जो ओवरऑल गेन था वो वाला. So that means what we can say that S will be equals to, it will be the ratio of, so change कितना होगा? del A by A. So this is the change in the gain of the basic amplifier, and numerator पे आएंगे change in the AF. AF is the feedback gain, मतलब overall gain, divided by AF. So this ratio will be called as the sensitivity of the amplifier, the sensitivity of the feedback amplifier. So now this S can be written as, I can write this as del AF by AF into capital A divided by del A. I can write this in this format. Now if you look at the AF formula, suppose we are using the negative feedback. So if we use the negative feedback, what will be the overall gain formula? That will be A divided by 1 plus A beta. Now if we derivative this equation, so that means we are derivating AF with respect to A. So del AF by del A. Why we are derivating this in this way? Because in this equation you can see we have del AF divided by del A into A divided by AF. So you want to find this ratio. So this ratio can be found from this equation by derivating the both side by A. So del AF by del A. So now what will be the value? So the value will be, if we derivative this, so नीचे होगा आपका 1 plus A beta whole square, और यहाँ पे होंगे 1 plus A beta into 1 minus, here it will be A into 0 plus beta. If we derivative U by V, so in the formula of U by V, d dt of U by V, so this will be the formula. So from this case I can find the value. You can see it is A beta, यहाँ पे भी A beta, so cancel out, so 1 will be there, so the numerator पे आपका 1 रहेगा, और in the denominator we will get 1 plus A beta, and that is whole square. Now we will replace this value, we have to replace this value here. So if we replace the value here, so what will be the equation? So S will be equals to 1 by 1 plus A beta whole square into A by AF. A by AF value put करते हैं. So if we put the value, so यहाँ पे A और AF is nothing but this equation. So A by 1 plus A beta. So A by 1 plus A beta. So this will be the equation. So now from this equation you can see that A will be cancel out. So this thing, this A will cancel out, and this 1 plus A beta will be cancelled out with the square. So that means S will be equals to 1 by 1 plus 1 by 1 plus A beta. So this is how the sensitivity equation looks like. So this is the sensitivity of the feedback amplifier if we use the negative feedback. Okay. So now in this case, this 1 plus A beta. So here 1 plus A beta is called the D, and D means the desensitivity. So desensitivity. So that means what we can say, that S is equals to 1 by D. So this is S, and S will be equals to 1 by D. Okay, and also this desensitivity factor is also called as 1 plus loop gain, because this A beta is called the loop gain. So these are different terminology that is used. So this is the loop gain, so we can say 1 plus loop gain. Okay, so in this case, if we want to write the AF using the D factor, so A by 1 plus A beta, we can say it, write it as A by D, or we can say it as A by 1 plus loop gain. So this is the equation you can see. We can write it in this format. So for what is the need of this sensitivity right now? So need of the sensitivity means, so for reliability of a system, the value of this sensitivity should be very, very small. So what we can say, that for reliability of a system, matlab feedback system, for reliability of a feedback system, the value of the sensitivity factor, that is the capital S, should be small as possible. Okay, as small. So for high reliability, what we can see, so we have seen that for high reliability, what we have seen, so for high reliability, if I write for high reliability, so for high reliability, what we have seen, we have seen that the sensitivity factor should be very, very small. That means it should be very, very less than 1. So that means 1 by D should be very, very less than 1. So D means 1 by 1 plus A beta, that will be very, very less than 1. So that means 1 plus A beta factor should be very much greater than 1. So what we can say, that A beta factor, that is the loop gain of the feedback amplifier, should be greater than 1. So this is the important concept, that for high reliability of the system, that is the feedback amplifier system, the A beta value should be very, very greater than 1. So if the A beta value is very, very greater than 1, so what we can say from this equation, we can say from this equation that we can say what we can say from this equation. So from this equation, what we can say, that if A beta is very much greater than 1 for high reliability of the system, then the overall gain of the system, that is the AF, which was equals to A by 1 plus A beta, and in this equation A beta is very much greater than 1, so that means we can approximate 1 plus A beta as only A beta, because A beta is very much greater than 1, so that's why the AF equation will be equals to A by A beta. A will be cancelled, so 1 by beta. So that means for a high reliable system, the overall gain of the amplifier will be nearly equals to 1 by beta. Then only we can say that the system, that is the feedback system, will be of high reliability. So high reliability. Okay, so this is how we can find. Similarly, we can also say that we have already seen that the sensitivity value, what was the sensitivity value? Sensitivity value was del AF by AF divided by del A by del A. So isko humne, how we have written that? So we have written it using del AF by del A into A by AF. That was the equation. So now from this equation, what we have seen? We have seen that this was equals to 1 by 1 plus A beta. So if we write this equation like this, that del AF divided by del A, that will be equals to AF divided by, so AF will go there, del A by del AF. So we are writing in this pattern, so we have done a mistake here. So del AF divided by AF, that will be equals to del A divided by A into 1 by 1 plus A beta. So we can write this in this pattern. So this equation will also be helpful. So all the equations which will be very useful in the case of numerical, we are making a box of that equations. So all the equations marked by the boxes, that will be very, very important in the case of numericals. So let us go into the numerical. So a numerical says that if A is 100, beta is 10, del A by A is 10% due to the temperature. So what will be the change in the system? So it is a question of sensitivity, because del A by A value, that is the change in the basic amplifier gain, is given, and we have to find the change in the system. So change in the system matlab change in the overall gain of the system, and change in the overall gain of the system means that is del AF by AF. So what do we need to find here? We need to find that change in the system. So change in the system. So we need to find the change in the system. This means the change in the overall gain of the system. The same thing. So we know that this is nothing but the change in AF. So that means mathematically we can say del AF divided by AF. So we need to find this equation. If we need to find this equation, then what do we have to do? So this is the thing that we need to find. So now let us do the question. So if I do this question, so we know that from this equation, what we can see? So from this equation you can see we can find the value of del AF divided by AF is equals to del A divided by A 1 by A1 plus A beta. So if I use this equation, so what was the equation? So let us copy write this equation. So del AF divided by AF, and that is equals to del A divided by A, or in the bracket 1 plus A beta. So this is how we have to find. Now how to find the del A by A? So you can see that del A by A is given by 10%. So that means del A by A is equals to 10%. It is given 1 by 1 plus A beta. So A value is given, beta value is given. So 1 plus A value is 100, beta value is 10. So now if we calculate this, what will be the value? So if you calculate this thing, you will get near about 0.01%. So what you can see that we have an amplifier, basic amplifier. So this is the basic amplifier, and the basic amplifier has a gain of A. Now we are having a feedback, and the feedback path gain, it is given by beta. So this is the feedback, okay, and this is the mixture. So plus minus negative feedback we have used. So here it is V0, here it is Vs, and this is the feedback signal. So क्वेश्चन में क्या बोला गया है? क्वेश्चन में बोल रहा है कि आपका जो बेसिक एम्पलीफायर है, ये बेसिक एम्पलीफायर, the gain of the basic amplifier is changing by 10%. But if the basic amplifier gain changes by 10%, then the overall system gain, so overall system का gain होगा आपका AF. So this AF will only change by 0.01%. That is the advantage of the feedback amplifier. Due to some reason, if the gain of the basic amplifier changes, जैसे यहाँ पे reason क्या है? Temperature. So due to the temperature change, the gain of the basic amplifier has been changed by 10%. Then the effect of this change will be nullified or minimized by this feedback path. So due to the feedback path, due to the negative feedback path, the overall gain is not affected by same amount as it is affecting the basic gain. So basic gain is changing 10%, but the total gain will be changed by 0.01%. So that will be the advantage of feedback amplifier. Okay, so this is the advantage of the feedback amplifier. Now, so we have understood what is the feedback gain, feedback amplifier advantage also through this numerical. So if you take a simple example, suppose we are taking a simple example, that means यहाँ पे, here it is given that A is 100 value and A is changed due to the temperature. कितना change? How much it is changing? 10%. So that means the A value was 100, then it is changed by 10%. If it is changed by 10%, so what will be the value of A? So value of A will be 100 plus minus 10%, matlab 10. Either it will be 110 or it will be 90. But the AF value will only changed by 0.01%. Suppose if the A value is 100 before the change of temperature, so when the value of A was 100, so what was the value of AF? So AF value can be calculated as A value divided by 1 plus A beta, so 100 into 10. So if we calculate this ratio, so it is coming as near about 0.1%. Now this A value was providing the value of the total feedback amplifier gain is 0.1. Now the value of A has been changed by 10%. Suppose the value is 10 plus minus 10, because 10% change, either it can decrease or increase, that's why plus minus. Now in this case, what will be the value of the AF? So the value of the AF will be 0.1 plus minus how much? 0.01%. So there is a small effect on the total feedback amplifier gain. So this is the advantage of the feedback amplifier. So due to the change in temperature, our basic amplifier gain is changing by a huge amount, that is 10%. At that time, due to the feedback, the total gain of the feedback amplifier is changing by only 0.01%. Okay, so this is the advantage. Now we will go for a very important part of the feedback amplifier, that is the frequency response of the feedback amplifier. So what will be the frequency response of the feedback amplifier? So let us see. So feedback amplifier is there. So this is the feedback amplifier, and let us assume that we are using negative feedback. So here it is positive, here it is negative. So we are using negative feedback. So it is the negative feedback. Now if it is the negative feedback, then let us say the basic amplifier gain is A and the feedback path amplifier, that is the feedback path gain, is beta. So here VF, that is the feedback voltage, will come. Here that is the output voltage, and here the input signal, and here we will get Vi. Okay, we have seen that. So now so this thing is a feedback amplifier with a negative feedback. We have assumed the negative feedback here. Okay, so if it is negative feedback, then what will be the gain of the total amplifier? So gain of the total amplifier will be equals to A by, since we have used the negative feedback, so here it will be A plus A beta. So this is the gain of the feedback amplifier, total gain using negative feedback. Now we want to find the frequency response of this feedback amplifier. What do you mean by frequency response? We have discussed that in the class. That is how the gain of the total feedback amplifier, that is AF, will change according to the frequency of the input signal. That means we have given some input signal Vs. Vs is an input signal. Okay, so this is an input signal, and this signal means it will have some frequency F. So if we vary, so if this frequency is varied, then how the gain of the AF will vary. That is called the frequency response. Okay, so that means in the x-axis we have to plot the frequency F, and in the y-axis we have to find the AJ omega mod. That is the gain. AJ omega means the AF. This AF, if I write it in the terms of omega, so I am just writing it as AJ omega. Okay, AF means this A. So do not take this as the basic amplifier gain. So we are just writing A, but actually it is the total feedback amplifier gain. Now the frequency response of any feedback amplifiers using the negative feedback will be always in the simple pattern. So the pattern will look like this. The pattern will be looking like this. It will be a simple bell shape like this. So this will be the feedback amplifier frequency response of every feedback amplifier response using negative feedback. So the highest gain, what is the highest gain we are achieving? So let us say the highest gain value is A0. And in the class we have already discussed about the lower cutoff frequency, and this is the higher cutoff frequency. We have discussed this thing in detail in the offline classes. So this is FL, FH, and this decrease in the gain, this decrement, how much it was decremented? If you have seen the offline classes, that means 3 dB down. Always we have discussed 3 dB down. So if it is 3 dB down, then here it will be A0 by root 2. So this will be the lower 3 dB frequency, and FH is called as the higher 3 dB frequency. And the gap between the FL and FH was called as the bandwidth of the system. So this is the bandwidth of the system. So for every feedback amplifier, if we use the negative feedback, then the frequency response will look like this. And we have already discussed that this type of frequency response can be found using the low pass filter and high pass filter combination. We have done this in the case of BJT amplifiers. So you can see that within this response we are having high pass filter part and low pass filter part. So high pass filter, what was high pass filter? So we have already said this in the class, so we are just writing it. So for any low pass filter, the gain A j omega can be written as A0 divided by 1 plus j into omega by omega h. So लो पास फिल्टर के साथ आपका हायर कट ऑफ फ्रीक्वेंसी होता है. Okay, so if I write this in the linear frequency format, that is AJF, so it can be written as A0 divided by 1 plus j f by fh. Now if we want to draw, suppose we want to draw the response of our low pass filter. All these things we have discussed this thing in the previous classes of offline course mein. So this is F, this is A, JF mod, and the response will look like that. Low pass filter means it will pass the low pass frequencies, so low frequency pass honge. So if the low frequency are passed and the high frequencies will be blocked. Okay, so now this is the maximum gain A0, and if it is the maximum gain, then here it is A0 by root 2. So this corresponding frequency will be called as the higher cutoff frequency. So that means the frequencies below the FH will be passed, and the frequency above the FH will be blocked. That's why it is called low pass filter. So always remember, we have seen that low pass filter is associated with higher 3 dB frequency FH. Similarly, the high pass filter is associated with lower cutoff frequency. And in this case, if we want to write similarly the value of A j omega for the case of high pass filter. So for the case of high pass filter, it will be A0 divided by 1 minus j, and it will be omega L divided by omega H. What is omega L? Omega lower cutoff frequency. Similarly, we can write this A gain equation in terms of linear frequency f. That will be equals to A0 divided by 1 minus j into FL divided by f. Okay, so similarly, let us find or let us draw the frequency response of the high pass filter. So this is the high pass filter. Okay, so now let us say this is A, J, F, and this is F. So according to the definition of the high pass filter, it will pass the high frequencies and it will block the low frequencies. So the plot will look like this. The plot will look like this. Okay, so high frequencies are passed, and let us say the maximum gain is equals to A0, and here it is A0 by root 2. Okay, so this frequency is the lower cutoff frequency, and what we can say, the frequency above the FL will pass by the high pass filter, and the frequencies below the FL will be blocked. So this is the low pass filter response and the high pass filter response. Now what we will do, we will apply low pass filter with feedback and we will see what will be the effect, and we will also apply feedback path to the high pass filter and we will see the effects. So right now our motive is that if we apply feedback with the low pass filter, then what will be the effect on the total structure. So let us see. So that means this is the basic amplifier right now. So what will be the gain of the basic amplifier? So the gain of the basic amplifier will be this equation only. So this will be the basic amplifier gain, that is A0 by 1 plus j omega by omega h. So that's why I have written A0 by 1 plus j f by fh. So this is the basic amplifier right now. Now this basic amplifier will be connected with a negative feedback. So let us connect with a negative feedback. So if we connect it with a negative feedback, so this is the feedback path. Okay, so here it is the feedback path, and let us say this is the mixture. So if it is the mixture, so here this will be the input signal Vs, and here it will be the feedback signal. So that is, let us say, negative feedback, so positive negative. So Vf will come on this line, and here we will get Vi. So Vi will be equals to Vs minus Vf, and here it is V0, and the feedback path gain is beta. So this is the total circuit right now. Now we will want to observe what will be the effect of this feedback, negative feedback. So now if we want to find the effect of the negative feedback, so what will be the total gain of the system? So let us find. So if we want to find the total gain of the system, that means we want to find the gain of this dotted block. So if we consider this as a single block, if we consider this total system as a single block, then this block is having a gain of AF, and AF will be equals to A by 1 plus A beta. What is the value of A right now? The value of A is right now this one. So this is the value of A. So if we put the value of A, let us find what will be the value of AF. So now if we want to find the value of AF, so AF value will be equals to A0 divided by 1 plus J F divided by FH, and in the denominator it will be 1 plus A0 divided by 1 plus J F by FH into beta. Now if we just simplify it mathematically, just if we simplify it, so what we will get? We will get like this. So let us write this equation in this pattern. So we can write this equation in this pattern like this, कि numerator पे आपका A0, okay, and in the denominator we can write 1 plus J F divided by FH plus A0 into beta. Okay, now this equation can be further simplified in this form, that is A0 divided by 1 plus A0 beta total divided by, we can write it as 1 plus J F by FH 1 plus A0 beta. So this is the thing right now. Okay, so this is the thing you can see. So now in this case, if we assume, let us assume this factor A0 divided by 1 plus A0 beta, let us calculate this, denote this as A0 dash. If we denote this as A0 dash, and if we denote this as FH dash, then what will be the equation? The equation will be AF is equals to A0 dash divided by 1 plus J, and here it will be F by FH dash. So now the equation can be written like this. So now what we can see, that what is this A0 dash? A0 dash, we have seen that, we have assumed that A0 dash is equals to A0 1 plus A0 beta. Okay, and what is A0 beta? A0 beta is nothing but the loop gain. So what we can say, this is nothing but A0 divided by D. So this is called the mid-band. What is A0 dash? A0 dash is nothing but the mid-band gain of the feedback amplifier. So this is nothing but the mid-band gain. Hopefully you know what is mid-band gain. We have discussed this in the offline classes. So mid-band gain of the feedback amplifier. So this is the feedback gain, mid-band gain of the feedback amplifier. And what is this FH dash? So this thing, FH dash, this is called the higher 3 dB frequency, higher 3 dB frequency for for means we can write it higher 3dB frequency with feedback. So these two terms important. If we use the negative feedback, so feedback, if we use the negative feedback, then it decreases the mid. So A0 dash value is A0 by 1 plus A0 beta. So before the feedback, the midband gain was A0, but after the feedback, you can see the midband gain is not only A0, so it is divided by 1 plus A0 beta. So that means before feedback, A0 value was there as the midband gain, and after feedback, the midband gain is A0 by 1 plus A0 beta. That means the midband gain has been decreased. Similarly, before feedback, the higher 3dB frequency was only FH, and right now after feedback the higher 3dB frequency is FH dash, which is equals to FH into 1 plus A0 beta. So that means the higher 3dB frequency has been increased due to the feedback, but the midband gain has been decreased. So what we can say in the statement, what we can write, so this is a very important statement. So the first statement that we can write, that feedback means negative feedback. So feedback decreases. So feedback decreases the midband gain. So it is decreasing the midband gain. How much factor by it is decreasing? So it is decreasing the midband gain by the factor 1 plus A0 beta. Or what is this 1 plus A0 beta? It is nothing but the desensitivity D. Similarly, in the second statement, what we can write, that feedback increases the higher 3dB frequencies, higher 3dB frequency by the factor of D. Okay, so this is a very important thing. That means if we use the feedback with a low pass filter, the midband gain of the feedback amplifier will be decreased, but the higher 3dB frequency will be increased. Okay, so this is the case of low pass filter using the feedback. So right now what we will do, we will go for the high pass filter with feedback. So if we go for the high pass filter with feedback, so this is the high pass filter with feedback. So now similarly, let us draw the circuit first. So first of all, we are having a high pass filter. So let us say that this is an high pass filter circuit. So this is the input line, and here we are having the basic amplifier, and the basic amplifier is nothing but A0 divided by 1 minus J into FL divided by F. This was the gain of the basic high pass filter. So we are using that equation only. Now we are connecting a feedback path. So this is the input signal and this is the mixture, and we are using a feedback path gain beta like this, and it is taking the output line as the feedback path, and here we are finding the feedback voltage VF, and here we are getting VI, and this is the output voltage. So this is the high pass filter with feedback. So in the similar way, if we find the overall gain of the system, we are not derivating here. So you can see that here the overall gain, here the overall gain of the system, just find the overall gain of the system by putting the value of A as A0 1 minus J into FL by FH. So if you find that, if you can see that, you will find that it will be A0 divided by 1 minus J FL dash divided by F. What is A0 dash? A0 dash, as we have mentioned earlier, so this is the mid band. This is the mid band gain with feedback. With feedback, this is the mid band gain. And this portion, this FL dash is the lower 3 dB frequency. So it is the lower 3 dB frequency with feedback. With feedback. And surprisingly, if you do the derivation, you can see that FL dash value will be equals to FL 1 plus A0 into beta. So what does it mean? It means that as you connect the feedback, the lower 3 dB frequency will be decreased by a factor of 1 plus A0 beta. So the same statement can be written here. So if we write the same statement, so let us copy this statement. So if we copy this statement, the same statement can be written in the case of high pass filter with feedback. So here we can write for this case. So for high pass filter with feedback, we can say that the feedback gain decreases. So feedback gain will also be decreased. That means A0 dash value will be same as that previous one. That is A0 dash will be equals to A0 as it was in the case of low pass filter with feedback. So it will be 1 plus A0 into beta. So that's why we can say that feedback decreases the mid-band gain by the factor of A0 1 plus A0 beta or D. But in the case of high pass filter, feedback decreases the lower 3 dB frequency. So it will decrease the lower 3 dB frequency. Lower 3 dB frequency by the factor of D. Same thing. So what conclusion that we can find? So the first conclusion that if we say the effect of feedback. Effect of feedback means the effect of negative feedback. Effect of feedback में तो बोल रहा हूँ, but actually we are considering the negative feedback. So the first effect. So what is the first effect? The first effect is that the mid-band gain value will be decreased by the factor of the desensitivity, that is 1 plus A0 beta, or we can say that A0 by D. Second conclusion is that the higher cutoff frequency of the low pass filter will be increased by the same factor 1 plus A0 beta, or we can say FH into D. Another way, for the lower cutoff frequency, it will be decreased by the factor of same 1 plus A0 into beta, or you can say FL divided by D. So what will be the effect on the bandwidth? So after feedback, the bandwidth is BW dash. It will also be increased. So let us draw like this to understand this. I am just drawing the frequency scale. So if we draw the frequency scale, so we are having F here, okay, and let us say that this is the lower 3 dB frequency and higher 3 dB frequency before the feedback, before connecting the feedback. So after connecting the feedback, what happens? The new higher 3 dB frequency FH dash will be greater than the FH because it is increased. So that means we will get new higher 3 dB frequency at FH star. It will be on the right hand side, since FH dash will be greater than FH. Similarly, FL will be greater than the FL star because FL star will be decreased. So if FL value is decreased, so it will move in the negative left hand side direction. So it will be FL dash. So before connecting the negative feedback, our bandwidth was this one. This was the bandwidth before connecting the negative feedback, and after connecting the negative feedback, it will be this one. So our bandwidth will also increase. So that means by how much factor it will increase? It will also increase by the same factor, that is 1 plus A0 into beta. Okay, so this is nothing but the conclusion. So this thing is the main conclusion that you have to remember for the numerical. So let us put it in the box. All the things, all the informations which are put in the box will be important for the case of numerical. So for that case, using this concept, let us do a numerical which has came on the GATE examination. So here it is written, feedback factor is beta 10, A0 value is 100, FH is 10 kilo ohm, FL is 10 hertz. So let us find the new FH, FL and the bandwidth of the system. So in this case, before connecting the negative feedback, so what was the bandwidth? So let us say the bandwidth. So the bandwidth of the system will be FL value minus FH value. So what is FH minus FL, not FL minus FH. FH is the higher cutoff frequency or higher 3 dB frequency minus the lower 3 dB frequency. So we can say the bandwidth is equals to higher 3 dB frequency means 110 kilohertz minus 10 hertz. Okay, so now what will be the value? So from this you can see that it will be nearly equals to 10 kilohertz, because 10 kilohertz is very much greater than 10 hertz. So it will be nearly equals to 10 kilohertz. What is the gain bandwidth product? So GBW. So gain bandwidth product is nothing but 100 into 10 kilohertz gain and bandwidth product. So gain is 100 here and bandwidth is 10 kilohertz. So we can say it as 10 to the power 3 kilohertz is the gain bandwidth product. Now we are connecting negative feedback with this. Okay, so what we will do, so let us draw the circuit like this. Suppose right now this is the basic amplifier, okay, and this basic amplifier is having a gain value of 100 and it will be connected through a negative feedback. So here there will be the mixture. So this is the mixture. So we are using the negative feedback. So here the feedback path gain beta is given by 10. So this is the feedback path gain. So the output will come as the input to the feedback path, and the output of the feedback path which is going into the mixture is called the feedback voltage, and here it is the input signal, and here we have denoted it as Vi, and here it is the output voltage. Now we need to find all the things. So first of all, if we want to calculate the desensitivity factor, so what is the desensitivity factor? D, that is 1 plus A into beta. So what will be the value of 1 plus A into beta? That is 1 plus A value is 100 and beta value is 10. So A into beta is equals to near about, if I approximate, it will be 1000. It will be 1000. Now if we want to find the value of the midband gain after the feedback, so it will be A0 dash divided by A0 dash will be equals to A0 divided by D, जैसे we have seen here only we have seen A0 by D. So A0 value is given already in the numerical and D value we have already calculated, that is 1000. So right now the midband gain has been decreased to 0.1. So before feedback it was 100. As we connect the negative feedback, the midband gain has been decreased to a value of 0.1, very small. Now what will be the value of higher threading frequency FH dash? So FH dash value will be equals to the previous FH into the desensitivity factor. Previous FH was 10 kilohertz into desensitivity factor is 1000. So if we calculate this, you can see it will be 10 megahertz. Similarly, if we calculate the FL dash, so FL dash value will be FL divided by D. What is FL? FL is nothing but 10 hertz divided by D. D means 1000. So if you calculate this, you will get it as 0.01 hertz. So you can see the FL dash has been decreased and FH star has been increased. So bandwidth, what will be the value of bandwidth, new bandwidth after feedback? That will be equals to FH dash minus FL dash. So if you put the values of FL dash and FH dash, you will get that it will be near about 10 megahertz. So what will be the gain bandwidth product right now after feedback? So after feedback, the gain bandwidth product will be bandwidth into gain. So that means A0 dash into bandwidth dash. A0 dash value is 0.1 and bandwidth dash is equals to 10 megahertz. So what will be the calculation? You can see it is coming to be 1 megahertz, near about 1 megahertz. So this was also 1 megahertz. 10 to the power 3 kilohertz means 1 megahertz. So gain bandwidth product is same. So the gain bandwidth product of the amplifier before and after connecting the feedback path is same, but because the gain is decreasing and bandwidth is increasing, that's why the constant product is constant. So this is how you have to calculate the value of the gain bandwidth product. You can calculate the value of new bandwidth. You can calculate the higher cutoff frequency, lower cutoff frequency, all those things. Okay, so now we'll go a very important conclusion. What is the conclusion right now? Let us see. So conclusion is that if we have an amplifier, okay, so if we have, suppose here is an, I'm just making a conclusion. So this is an amplifier. This column is named as amplifier. This is the gain, this is the bandwidth, and this is the gain bandwidth. Now first of all, I am writing the feedback amplifier here. So feedback amplifier. So feedback amplifier means the gain will be decreased and the bandwidth will be increased, but the gain bandwidth product will be constant. For multi-stage amplifier, if you think, we have already studying the multi-stage amplifier in the offline classes. I am just comparing the multi-stage amplifier with the feedback amplifier. So in the case of multi-stage amplifier, if you remember, the total gain, mid-band gain was increased, but the bandwidth was decreased. That's why it was also constant. But in the case of negative feedback amplifier, here the gain is decreasing, but in the case of multi-stage amplifier, the gain was increasing, but the bandwidth was decreasing here. And here in the case of feedback amplifier, the bandwidth was increasing. That's why in the both case, you can see that the gain and the bandwidth product will be constant, but the decrement and the increment nature of the gain and the bandwidth is just opposite to each other. Okay, so now in the case of this thing, this is the total conclusion of the feedback amplifier, how the gain and the bandwidth and how the higher 3 dB frequencies and lower 3 dB frequencies changes with the connection of negative feedback. And we have also compared that thing, that is the negative feedback effect on the amplifier with the multi-stage amplifier cases. And we have seen that the multi-stage amplifier gain varying, a change of the gain and the bandwidth in the case of multi-stage amplifier is just in the opposite direction of the feedback amplifier cases. Okay, so this is how we can analyze the feedback amplifier. And in the next class, what we will do, we will try to understand different types of feedback topologies. So there are different types of feedback topologies. We have to understand the feedback topologies, all feedback topologies, by a very deep concept, using a very deep concept. Otherwise you will be unable to solve the questions in the GATE examination. But there is a small trick by which we can find the feedback topologies very easily. We will also discuss that in the class, okay, in tomorrow's class. So in tomorrow at 9 9 o'clock, that is 9 o'clock in the morning, we'll see the feedback topologies and we'll complete the total chapter of feedback amplifiers. Okay, so hopefully you have enjoyed the class. Thank you everyone. Thank you.